It's been many years since a prosthetic elbow has come to market. Our goal with this product was to make something that was comfortable for the end user as well as fit with their daily lifestyle. Some of the key characteristics that play into that are battery life, the weight of the prosthesis, as well as performance. One of the biggest challenges in developing this elbow was to accommodate the ever-increasing power requirements of terminal devices, and I think we accommodate that in this design.
The battery pack has 3,000 milliamp hours and it's 10.8 volts. So it's a pretty big battery pack compared to competitors. Not necessarily big in size, just big in power. The big difference is a lot of battery packs on the market right now are lithium polymer. This is a lithium ion, 18650 cells. They use these to power cars. They're used in all kinds of applications. We're able to supply the proper amount of power to not only just a hand or just an elbow, but things simultaneously functioning together. So our battery pack is able to, close your hand on something and the elbow move, and it's not going to stall out in one degree of freedom. For motor selection, we wanted it to be powerful. We selected a brushless DC motor that could provide the needed torque to lift not only a hand but weight, but also the speed to provide during flexion and extension. When wearing a prosthetic, one of the biggest concerns is weight. And more importantly is where the placement of the weight is. So when you're wearing a prosthetic, the more weight you have out towards the hand and wrist, the heavier it feels on the body because it pulls down on the socket, pulls down on your limb. So it was really important for us to have that weight as far back or as near to the elbow joint as possible. Looking at a motor solution, a motor and gearbox solution for the Espire Elbow, there are things currently off the shelf that manufacturers design. However, they look like this. So this obviously does not fit well inside of a shell. That's not what we want. We want something that fits within this elbow portion of the shell. So if you see that, it doesn't fit. We had to reduce our gearbox in order to fit within that space. We wanted to provide a solution that was not only reliable, but met all the specs and improved upon that. So throughout the design process, through the motor selection, through the iterations of gearboxes we made, we kind of evaluated them and looked at them all to make sure that they were what we wanted to design.
The next step to this is actually getting on a person. That will be the real test as far as does it perform and meet the original design goals. And I think in typical College Park fashion, we'll always be working on this project because we want to make the best product for the end user.